Good morning, children. In Unit 3rd, Magnetic Effects of Current, we have next topic is Biot savarts law. In the original experiment, we have studied that whenever current is passing through a conductor, then magnetic field is produced around the conductor. And in the Biot savarts law, it is used to find the magnetic field intensity at any point due to the current carrying conductor. Here, AB is a current carrying conductor. Current I is passing through the conductor. Let us suppose dl is a small length of this current carrying conductor, and we have to find the magnetic field intensity at the point P at a distance r from the small length element dl. So this r is the distance between the point P and the small length element dl. Now this point P makes this point P at a distance r which makes an angle theta with the conductor. It is observed that when the current is passing through the small length element, then small magnetic field is produced, and magnetic field dB depends upon some factors directly proportional to the current. If the current increases, magnetic field increases. Second, magnetic field directly proportional to the current element, this is dl. Now dB inversely proportional to the 1 upon distance, so dB inversely proportional to 1 by r square, and magnetic field is directly proportional to the angle, so it is sin theta. Now if we combine all these terms, then we get dB proportional to I dl sin theta upon r square. Now we can write dB is equal to k. This is I dl sin theta upon r square. Here k is a constant. The value of k is mu naught upon 4 pi, where mu naught is absolute permeability of free space or vacuum. The value of mu naught is 4 pi into 10 power minus 7. So now we can write mu naught upon 4 pi, this is equal to 10 power minus 7. So now we can write Biot savarts law as dB is equal to k. The value of k is mu naught upon 4 pi into I into dl into sin theta upon r square. In vector form, dB is equal to mu naught upon 4 pi into I into dl cross r upon r cube. So this is the vector form of Biot savarts law. In Biot savarts law, the application is that magnetic field intensity at any point on the axis of a current carrying circular wire. Let a circular wire of radius capital R and the current I is flowing in the circular wire. we have to find the magnetic field intensity at this point P here. Now let a small current element, this is dl, and the direction of the current element dl is from B to A, like this. Now at the point P, when the current is passing from the small current length element dl, then small magnetic field will be produced. So at the point P, the small magnetic field, that will be dB. Now to find the direction of the magnetic field intensity, suppose this is a circular ring and this is length dl, small length dl. This is the direction of this. Now apply the right hand thumb rule. Now curl your finger and it will be upward. So it will be upward and perpendicular to the plane of the coil. So we can say here, this is the distance is r. So dB will be perpendicular on this line. So it is dB. If this is angle theta, then it is also angle theta. Now we can resolve dB into two parts. First dB cos theta and dB sin theta. Now you can see here that this line having distance r, it makes an angle 90 degree with this dl. Similarly we can do like this. This is a circular wire and this is a line. You can see this is perpendicular, makes angle 90 degree. If it is turned by some angle, then it will also make an angle of 90 degree. So this dl and this one, it makes an angle of 90 degree here. As we have taken small element dl in the just diametrically opposite to it, it is also a dash into b dash. Now same length dl, direction of this is from like this. This is dl and the small current is passing from this point a dash and b dash, which is of length dl. Then small magnetic field dB will be produced. Now we can resolve dB into two components, dB cos theta and dB sin theta. Here in this diagram, dB cos theta and dB cos theta, they will cancel each other because they are equal and opposite. So they will cancel each other. Only component which is left, that is dB sin theta and dB sin theta. If we take small element dl at any point, so we get small magnetic field, that will be dB, and if we resolve, then we get only component dB sin theta. So here are many components of dB sin theta. If we integrate them, then we get the total magnetic field. Now according to Biot-Savarts law, we can write here dB is equal to mu naught upon 4 pi into I dl into this is sine. This is angle of 90 degree. This is sine phi upon r square. Here angle phi is 90 degree. So this is sine 90. dB equals to mu naught upon 4 pi into I dl into sine 90 upon r square. Sine 90 is 1. So we get dB is equal to mu naught upon 4 pi into I dl upon r square. Now the total magnetic field B is equal to integration of dB sin theta. Put value of dB mu naught upon 4 pi I dl by r square into sin theta. We can integrate dl. The integration of dl is, that is 2 pi r. Here we can write this is 2 pi r. From the diagram we can find the value of sin theta, that is equals to capital R upon small r, that is capital R upon small r. Now in the diagram, this is point O, distance between O and P is x, capital R, and this is small r. So by Pythagoras theorem we can find r is equal to under root r square plus x square, and we can write r square is equal to r square plus x square. Now we can put the value of B. B is equal to mu naught upon 4 pi 2 pi I r square upon r square into r, that will be r cube. So we can write here r square plus x square, this is power 3 by 2. So this is the required result to find the magnetic field intensity at any point on the axis of a current carrying circular wire.